Hello friends, welcome to BISP Solutions. Myself Ashwin and I work as a technical consultant at BISP Solutions. BISP Solutions is a tech company and provide technological solutions across the world. Now in this video, I am going to show you how to apply polynomial regression on sales order data from NetSuite, right? In my last video, I recommend you to watch that video. I have shown you how to apply linear regression, how to predict the data using linear regression algorithm. In this, we are going to see polynomial regression. Polynomial regression is more accurate than linear regression. So that is why we are going to use this. And in this, we use the power. We increase the power. For example, now see here, polynomial regression is a form of regression analysis in which relationship between independent and dependent variable y is modeled as an nth degree of polynomial. Now, let me show you this. Right, nth degree of polynomial in x. Now, see here, you can see here b0, b1 x1, and then b2 x1 to the power 2, bn x1 to the power n. So we increase the power, the more accuracy we can predict, right? We can predict the more accuracy. Let's suppose we are having the sales order data of past few months, and we want to predict the data. So instead of using linear regression, we are deploying here polynomial regression. Now here polynomial regression, this formula is used, y equal to b0 plus b1 x1 plus b2 x1 square and up to n number. And the power we raise, we get more accurate prediction. So how this all works, I will explain you practically. So let's go to first NetSuite. I have created one sales order search, saved search, in which I have collected all the sales order for the last few months, right? I have downloaded this sales order saved search and named it as, let me show you, financials. Here, this is the financials Excel sheet, right? So I have downloaded that Excel sheet and named it as financials. Now let's go to our Jupyter notebook. Now in this Jupyter notebook, you can see first of all, I have opened the Jupyter notebook. Those who are not familiar with Jupyter and Anaconda application, please put it down into the comment box. I will prepare another video for that, right? So now let's see this. I have opened the Jupyter notebook. Right now, I have not done anything. I will show you from the beginning. Import pandas library as PD, import numpy library as np, import math library, import matplotlib pyplot as plt. That means it is for plotting diagrams, right? Then shift enter. Now these are imported, so nothing will be visible. Then financial data equal to pd dot read csv, and this is the path of this financial, right? Financials csv. And then I have put here financial data and then shift enter. Now see here. Actually, I have removed unnecessary records, unnecessary columns. I have kept only company, item name, item price, total revenue, profit, month, number, year, right? Now see here, you can see country name, right? And the item name. So country name, since the algorithms does not work on text, so we have to make dummies here, and we have to make separate columns for all these countries and to convert it into numerical. So wherever the Germany is written, for example, this, wherever Germany is written, in that case, in place of that, 1 or 0 will be written. So financial data pd.get dummies. Now here dummies is a function, is a property, and then we are making use of it. Financial data type is int. Then financial data columns, and then shift enter. Now see here, these dummies are created, right? These are actually one type of columns, right? These are the columns. Now what we have taken, variable x, financial data, these are the columns that we are taking as a series inside this, and y is the variable in which profit is taken. So in this way, two different data sources are created, right? X and y. Now I again press shift enter. You will see, right? After that, Right now, ignore this, whatever written. First, see this from sklearn.model selection, import, train, test, split. Now, see, whenever we apply any algorithm, in that we have to keep 80% of data in training data and 20% data in testing data. So that's why we have to create variables x train, x test, y train, y test, right? Equal to train test split, train test split, and then x y test size 0.2. 0.2 means 20% data we are keeping for testing purpose. And then random stat, that is 51, right? Now, if you see here, xtrain.shape, xtest.shape, shape means exactly the number of record counting. So here they have shown xtrain record count, then ytrain, ytest, right? So all these are, they are just showing the counting, right? Now, let's come here. If you see this from sklearn.linear model, import linear regression. Here why we have imported linear regression. Right now, I will show you linear regression part. Now see here, LR equal to linear regression, LR dot fit as per our previous video. Again, we are going to fit the data, X train, X test, X train and Y train. LR dot score, X test and Y test. These are the variables we are using. And then I press enter. Okay. Now, if you see here, Y underscore pred. Now LR dot predict X test. Now we are predicting the data y underscore pred. LR dot predict x underscore test. So we are predicting the test data, right? Now if you see here, predict a variable, predict df data frame, pd dot data frame actual value. What is the actual value? Y test. Whatever we receive from y test testing data, predicted value, that is y pred, that is the predicted data. After that, difference, we are taking the difference also. Now here I have written pred df means it will print the df data frame. Again I am hitting shift enter. Now see here, if you see actual value is this, predicted value is this. Now see, there is a too much difference, 2000, 4000, 1000, 70,000, 8,000. So there is too much difference between the actual value and predicted value. So that is why when we plot a graph, import seaborn.sns. This is a library that we are using, seaborn library, and sns.reg plot x equal to y test, y equal to y pred. And we have, this is a standard way of plotting the data. So there is nothing technical here. This is the standard way of writing, right? So you can just memorize this, right? Then I'm entering shift enter. Now see here, if you see this line, it is covering very few dots, right? Most of the dots are not covered. So this is inaccurate. Now what I am doing, from sklearn pre-processing, import polynomial features. Now we are importing polynomial features library, and then poly underscore reg polynomial features degree 2. Now see, degree 2, that means here up to this level, b0 plus b1 x1 and then b2 x1 power 2, right? So this is our first increase the power, right? I have increased the power. Now if you see degree polynomial fit x train, so again we are fitting the data x train, right? Then x train poly underscore reg and transform x train. So it is transforming the data as per y and x axis. So x test poly underscore reg and then transform x test. Okay. So LR equal to linear regression. That means we have created one instance LR. Now LR dot fit. Again, same thing, just like a linear regression, LR dot fit x train polynomial and y train. Right? Here is x train polynomial and that is another is y train. And in this way, we are going to see y underscore pred, y prediction of y equal to LR dot predict x underscore test underscore poly here. Okay. Now prediction underscore df equal to pd dot data frame, actual value, then predicted value, just like we have done few minutes back, right? Then the difference equal to this. Now let's print this prediction of DF. Okay, I am entering shift enter. I am hitting the button shift enter. Now see a curved chart. Just a second. Wait. If I enter this, then I enter this. Okay. Now you can see here a curved chart is created now. This chart, yes. Now you can see a curved chart is created. After that, here, but still most of the dots are not covered. In that case, we increase the degree now. We are increasing the degree in polynomial feature. So polyreg means it's a variable polynomial regression. Polynomial features degree equal to 3. Again, polynomial regression dot fit x10. We are fitting the data of x10, and then x10 polynomial poly underscore reg transform x10. That means it has to transform the data. Then x test poly equal to poly underscore reg transforming again x test, x10 and x test. So it is transforming the data, and LR equal to linear regression. Since linear regression we have taken here, LR dot fit, again the same thing. We have taken linear regression, we are fitting the data, and then if you see here, plot regression degree 3. Now Y prediction, LR dot predict x test poly. X test poly is this X test poly, right? So in this way, when we increased the degree, then you can see here the curve is little bit different. It is covering some other more number of points, right? After that, now let's do one more thing. Again, increase the degree. Now again, increase the degree means polynomial feature degree equal to 4. Now polyreg fit x10. Again, we are putting the same x10 data, right? So x10 underscore polynomial poly dot underscore reg transform x10. Again, we are transforming the data for plotting, and then LR equal to linear regression LR dot fit. We are fitting the data x10 poly and y train, and let's see what happens here. Y underscore prediction LR dot predict, right? X underscore test polynomial. So SNS dot reg plot, again the same, it's a standard structure. You can memorize it, or you can just paste it as it is, right? Now you can see here maximum number of dots are covered, right? You can see here. So in this way, we apply polynomial regression to predict the data, to predict the profit, that for so far we are having this much profit. So based on this past history, how can we predict the data? So this is how it works. So that's why I have shown you the code also in working state. So if I click on this, again, now look at this. It has changed, right? So polynomial regression, in which we increase the degree, the more we increase the degree, the more accurate data we receive. That is called polynomial regression. So I recommend you to first watch my previous video and then practice also. This is the polynomial regression chart, right? It shows as a curve. So I recommend you to practice this, because in first attempt it seems to be difficult, but it's not so difficult, right? So practice this, and if you face any difficulty, then you can put it into the comment box. I will resolve it. And those who are new in this channel, they can please subscribe my channel. Thanks guys. Thanks for watching the video. Thank you.